Module 1, Principles and Fundamentals of Irrigation Engineering. Lecture 1, Introduction to Irrigation and Drainage Engineering. Welcome to this course on irrigation and drainage engineering. Agriculture and water management are closely connected. Irrigation ensures crops receive adequate water for growth, while drainage removes excess water to prevent soil damage. This field combines hydrology, soil science, and engineering to maximize agricultural productivity while preserving soil and water resources. Irrigation engineering is the science and art of applying water to land to assist in the growth of crops. Proper irrigation improves yield, stabilizes production, and allows cultivation in areas with insufficient rainfall. Drainage engineering, on the other hand, ensures that excess water is removed efficiently to prevent waterlogging, salinization, or erosion. The primary objectives of irrigation and drainage engineering are: to ensure optimum crop production, to manage water resources efficiently, to maintain soil health and prevent degradation, to protect crops from water stress or excess water. Lecture 2, Principles of Irrigation. Irrigation principles revolve around supplying the right amount of water at the right time to meet crop needs. Some key principles include: water requirement, calculating crop water needs based on evapotranspiration, crop type, and growth stage. Water distribution, ensuring uniform application across the field to avoid over-irrigation or under-irrigation. Efficiency, minimizing water losses due to evaporation, runoff, or seepage. Scheduling, timing irrigation to coincide with critical crop growth periods. Irrigation scheduling requires knowledge of climate, soil properties, crop type, and water availability. Accurate scheduling helps conserve water and ensures optimal crop growth. Lecture 3, Sources of Irrigation Water. Irrigation water can come from multiple sources. Surface water, rivers, streams, reservoirs, or lakes. Surface water is abundant but can vary seasonally. Groundwater, wells, boreholes, or springs. Groundwater is often more reliable but can be costly to extract. Rainwater harvesting, collecting and storing rainfall for irrigation purposes. This is sustainable and environmentally friendly. Recycled or treated water, wastewater from domestic or industrial sources can be reused after treatment. Each source has advantages and challenges. Effective irrigation engineering requires selecting the most appropriate source based on availability, cost, and environmental impact. Lecture 4, Methods of Irrigation. There are several methods of applying water to crops, each with its advantages and limitations. Surface irrigation, water flows over the soil surface to reach crops. Types include furrow, basin, and border irrigation. It is simple and inexpensive but may lead to uneven distribution if not properly managed. Sprinkler irrigation, water is sprayed over crops like rainfall. It is suitable for various soils and terrains but requires energy for pumping. Drip irrigation, water is applied directly to the root zone through emitters. It is highly efficient and reduces water loss but has higher initial cost. Subsurface irrigation, water is delivered below the soil surface, reducing evaporation losses. It is suitable for high-value crops and controlled irrigation systems. Selection of the method depends on crop type, soil conditions, water availability, and cost considerations. Lecture 5, Soil-Water-Plant Relationship. Understanding the interaction between soil, water, and plants is central to irrigation engineering. Soil water retention, soil can hold water at different tension levels. Sandy soils drain quickly, while clay soils retain water longer. Field capacity, the maximum water soil can hold after excess water has drained. Permanent wilting point, the water level below which plants cannot extract water and begin to wilt. Available water, the portion of water between field capacity and permanent wilting point that plants can use. Proper irrigation planning ensures soil moisture remains within the optimal range to support crop growth without causing water stress or waterlogging. Lecture 6, Design of Irrigation Systems. Designing an irrigation system involves several steps. Assessing water availability, quantifying the amount and timing of available water. Selecting the irrigation method, choosing the appropriate irrigation technique for crops and soils. Calculating water requirement, estimating crop water needs for specific growth stages. Determining field layout, planning field shapes, furrows, basins, or sprinkler coverage. Sizing conveyance structures, designing canals, pipelines, pumps, and reservoirs to transport water efficiently. A well-designed system improves efficiency, reduces wastage, and ensures optimal crop production. Lecture 7: Principles of Drainage Engineering. Drainage engineering removes excess water to protect crops and soil. Excess water can lead to waterlogging. Saturated soils reduce oxygen availability for roots. Salinization, accumulation of salts due to poor drainage. Soil erosion, flowing water removes topsoil, reducing fertility. Drainage systems are designed based on type of drainage, surface or subsurface. Hydraulic properties of soil, permeability and water table depth. Crop tolerance, some crops can tolerate short-term waterlogging. Surface drainage removes water from field depressions, while subsurface drainage uses pipes or ditches to lower water tables efficiently. Lecture 8: Drainage Design and Planning. Key steps in drainage system design include surveying the field, understanding topography, slope, and soil type. Determining water table depth, ensuring it stays below crop root zones. Selecting drainage method, open ditches, tile drains, or mow drains. Sizing drains and outlets, calculating the capacity to handle maximum water flow. Maintenance planning, designing for easy cleaning and repair to sustain performance. Efficient drainage reduces crop losses, improves soil aeration, and supports long-term agricultural productivity. Module 1 Summary. In this first module, we have covered the fundamental principles of irrigation and drainage engineering. The importance of water management for agriculture. Water sources and irrigation methods. Soil-water-plant relationships and water requirements. Designing irrigation and drainage systems. These concepts provide the foundation for understanding how to manage water efficiently in agricultural fields.